Thanks very much. Well, nice to see you all here today. I realized that a month ago it was exactly 25 years since we started working on the development of Mathematica. So it's a long time. That means in 2013 it will be the 25th anniversary of the launch of Mathematica. I thought maybe I would start off by remembering a little bit the old days and seeing how things have changed. So you might remember, who remembers this? Remember that? Okay, good. I thought we might actually see if the bits are still intact or whether they've all rotted. Let's take a look. Remember these? Well, let's see what we can do here. All right, let's see if Mathematica still launches after all these years. Funky splash screen there. I wouldn't be so sure yet. Let's see what happens next. Starting the Mathematica kernel. Okay. Now look at that weight cursor. That's a stylish weight cursor. See what happens here.
We can't see.
You can't see? Up.
There we go. All right.
There we go. Let's try something like this. Oh, I didn't remember that. Okay. Well, let's try something. There we go. Well, let's try something. Let's try 123 to the power 123. Okay. All right, still works. So far, so good. So I thought we might start off by seeing kind of how the world has changed since then. There's actually, well, many things have happened. Many of you will have seen our online scrapbook, kind of going through some of the stages in the evolution of Mathematica. But just to give us some indication of what's changed in the world, I have here an iPhone 4S, and let me try connecting to this and see what we can do with this. Okay, so I thought we might just try doing the same computation, that 123 to the power 123 on this thing, using sort of the latest as of last week technology. So let's give this a try. What is 123 to the power 123?
Checking my sources. I found this for you.
So that's the Siri intelligent assistant running on iOS and calling our Wolfram Alpha system to get its computational results. Well, it's kind of fun actually to see the arc of not only of Mathematica but also of Apple from the Mac to the iPhone and so on. We've had great interactions with Apple for a long time. In fact, as some of you may know, in the sort of ancient history, when Mathematica was first coming out, one of the early kind of business arrangements that we made was for Mathematica to be bundled on the next computer. And in fact, Steve Jobs, who was the person who made that deal happen, was also the person who pushed us to name Mathematica Mathematica. So that's another contribution that was made there. It was very disappointing to see that Steve Jobs died just a day after this Siri intelligent assistant and the iPhone 4S was released. I happened to find recently a video that Steve sent us on the 10th anniversary of Mathematica, and I thought I might show that because it's kind of interesting to see.
Stephen, congratulations on 10 great years of Mathematica. Having seen it from the start, having had a chance to work with you while you were developing it, having the first version be on the Macintosh and doing a great version on Next Step together, it's been a great ride. And Mathematica's changed everything. It's in use in every major university, in most major corporations. And one thing we're really excited about here at Apple is that just as Apple is re-entering the consumer market with a vengeance with iMac, you guys are going to be coming out with some versions of Mathematica for consumers and for K-12. And we are super excited about working with you to make the next 10 years of Mathematica even more successful than the first. So happy anniversary. Congratulations.
It's kind of remarkable what happens in 13 years. At that time, Apple was a troubled company, and just before it started to really get in gear and do all sorts of exciting things. So that was nice to see. Well, I think we've come a long way since Mathematica version 1, the so-called system for doing mathematics by computer. I like to think that we sort of conquered the territory of system for mathematics by computer, and so have started building out in just a huge number of other directions that I'll talk some more about today here. Well, last year's conference, we had just finished Mathematica version 8, and we're just about to release it. Mathematica version 8, you might remember, had many interesting and important features. First time we'd introduced symbolic probability and statistics capabilities, lots of things in areas like group theory and so on. First, the introduction of our image processing system for Mathematica, introduction of lots of built-in capabilities for graphs and networks and so on. Also, the beginnings of support for control systems, built-in financial computations, wavelets, all sorts of software development capabilities like faster compiled functions, symbolic C capabilities, support for GPUs, things like this. All sorts of nice new charting and visualization functions, and a certain collection of new user experience features. So, and I guess the headline feature of Mathematica version 8 was integration with Wolfram Alpha. And just to remind people, one of the things that happens with integration with Wolfram Alpha is that because Wolfram Alpha gets updated every week, things change and get enhanced in those kinds of connections all the time. So as we recall, we can do things like, say, plot sine x squared. You don't have to know Mathematica syntax anymore. You can just use the freeform linguistics capabilities of Wolfram Alpha to be able to convert your freeform linguistics into precise Mathematica code here. Or we could go ahead and say something like add a green frame or something to this, and then it'll go and send that freeform linguistics to Wolfram Alpha, come back here. Now we could do image processing. We could say blur the image. Can do that. I find, even though I consider myself an expert user of Mathematica, I still find this freeform linguistics quite useful. If you say something like, let's say something like this, you can, that will tell you, it will sort of immediately give you the version of that sort of free-form question, GDP of France, in terms of Mathematica's built-in country data capabilities. And of course, every time you do one of these computations, what you get out is something which is completely manipulable within the Mathematica language and so on. Well, so there are all kinds of interesting things that that one can do with Mathematica. By the way, one thing I might mention, there's now a Mathematica Tip of the day, a Twitter feed, which reminds us all of interesting things that can be done with Mathematica on a daily basis. Well, time was long ago when we were a company that really just had one product, namely Mathematica. Probably our second really big product has been Wolfram Alpha, and we've been continuing very energetically to develop Wolfram Alpha, and in Wolfram Alpha, the capabilities of Wolfram Alpha have been expanding dramatically. Let's just start off making sure it's alive and well this morning. Yeah, there we go. It's interesting that in Wolfram Alpha, kind of the design methodologies approaches are very different from Mathematica. Mathematica is this very precise system that has a precise language that lets you kind of build everything up in a good engineering kind of way. Wolfram Alpha kind of starts by a kind of drive-by experience where you just wonder about some particular question. You type something in very quickly. We get to see sort of raw representations of human thoughts, I think, because people type all kinds of things into that input field. They sort of tumble out in mixtures of English and notation and so on. And then in Wolfram Alpha, we're using sort of boatloads of heuristics to understand what people mean and to figure out how to compute things and then to generate kind of reports as output. And this idea of generating reports as output has turned out to be much more important than I expected it would be. If you ask, I don't know, what is the, I don't know, something like US banana consumption or something. Wolfram Alpha should know that along with many, many other things that it knows. But just to get that one answer of such and such a number of short tons per year is much less useful than knowing what the world rank is and knowing a historical plot and knowing comparisons with other things and so on. And also the ability to sort of take this kind of free-form linguistics that's kind of looking at thinking about things the way people kind of would talk about them turns out to be very powerful. A thing that's been a surprise to me, kind of the objective in Wolfram Alpha is to make sort of as much knowledge, as much systematic knowledge that exists out there in the world as possible computable, in the sense that you take, if there's a question that sort of can be answered on the basis of kind of expert level knowledge, the idea is that Wolfram Alpha should be able to answer that question automatically. And there are several components to doing this. We have to have sort of a systematic sources of data. We have to take sort of the underlying raw data and make it computable. That's a huge thing that's done with a kind of pipeline of mathematical automation together with human expert input. Make the data computable. Then we've got to kind of, from the data, we've got to actually compute things using methods and models and algorithms and so on. And we've been sort of steadily implementing kind of all kind of known methods and models and algorithms from all sorts of different fields of science and engineering and all kinds of areas of analysis. Nowadays, the internal code of Wolfram Alpha is about 15 million lines of Mathematica code. So it's a pretty big system. Another component to it is understanding free-form linguistic input, something that we at the beginning thought might be just dead impossible. There might just be too much ambiguity in sort of typical human language and so on. It's turned out now, for the kinds of things that people, for example, type into the Wolfram Alpha website, we're now above 95% probability of being able to interpret what the input means, which I think is extremely impressive. And for example, for an area like math, I think we're really pretty close to 100%. And the things which we can't do, you show them to humans, and humans are scratching their heads and not knowing what on earth the person could possibly have meant. So we think we're off the hook in those kinds of cases. So the thing that's kind of surprised me in the development of Wolfram Alpha is kind of how much stuff out there in the world is actually computable. Like, let's say, you have an oak tree in your backyard and it's 30 years old. You can compute. We've got some folks from the US Forest Service were kind enough to give us a database of 1 million trees, and from the database of 1 million trees we can see the forest or something. We can do all sorts of computations about growth curves and so on, and we can estimate, for an oak tree of age 30 years, what will be its average height, and what are some distributions of height distribution for trees in Illinois, and all sorts of things like this. There's the height distribution, I guess, for all trees in the US of that type, and these kinds of things. It's just remarkable how much stuff can actually be computed in the world. And you can do all sorts of much more technical computations. Let's see what happens if I type something. Well, no, that's not a good idea. Let's try, let's say something like this. A 50 MeV gamma ray in water. See if we can compute that. So we can, in this case, we can compute all sorts of characteristics of absorption of that radiation in water and so on, just a random example. We can look at lots of socioeconomic information. I don't know, let's say we ask about Chicago public schools. How about that? now we've got, I hope, all sorts of data. Okay, there are 638 public schools in Chicago. Let's see what we, and we know the total number of students, and let's see what else we can compute here. Oh, there they all are. Maybe we can go ahead and look at the one with the most teachers. Okay, and we can drill down and find out all sorts of things about that school and so on. Or we can look at things which are much more real-time in character, like let's say we say something like flights overhead. That should, oops, that's based on the current GeoIP location. That's telling us, okay, if we looked up in the sky, those are the planes that we should see right now, based on an FAA feed. So let's see what we can look at here. Let's try this this plane. How about this one here? Let's look at more details here. This is a plane going from to Milwaukee from Memphis, and there's its route of flight, and you can see there's how far, where you can see that plane from. And for example, down here, okay, we can see there's the altitude of the plane as a function of time and so on. It's really kind of remarkable how much stuff you can actually compute about the world, and how much you can kind of, when you start combining all these different things that can be computed, what you can get. Well, we've been kind of really developing Wolfram Alpha to sort of cover more and more different domains of data, and I think it's been very nice to see that we've becoming very well recognized as sort of the broadest aggregator of systematic data in the world. For example, we've been organizing a data summit in Washington, D.C. We just had our second one of these, where we're inviting sort of the leaders of the world's large data repositories, most of whom we're working with now in Wolfram Alpha in one way or another. We also were, as something to try to understand kind of the whole story of data, we realized we're in an old business. This is a kind of a timeline of the world of systematic data that we made. I think you can even get these now. They got printed. It goes from the Babylonians over there up to modern times over here. It's actually remarkable. I think the two largest single entities contributing to sort of systematic data in the world have probably been the Babylonians and the United States government, and we could sort of trace the history of these things. It's quite interesting. There's a version of that data poster actually on the web as well. So in terms of Wolfram Alpha, there's many things going on. Let me just show you sort of the way that one can. One of the ways that Wolfram Alpha is used is by humans coming to the website or whatever. Another important use of Wolfram Alpha is by programs and computers, and for that one's using the Wolfram Alpha API. This is an API explorer that shows if you sent 2 + 2 to this API, there's the lump of XML that you would get out. And that lump of XML is easy to interpret for a program, and this is the way that sort of all the applications of Wolfram Alpha work, whether it's the client for Wolfram Alpha inside Mathematica, whether it's the Siri system on the iPhone, they're all using this Wolfram Alpha API, which is now a pretty well-developed and an efficient API. Well, one of the clients for the API are applications, apps, on mobile devices and so on. So, for instance, probably seen the main Wolfram Alpha app, complete with its. We get to use all these soft keyboards and so on here, so we can go ahead and type in. And do computations here. In addition to this app has actually been pretty systematically the best-selling app in the reference category on the iPhone. There's also a version of the app for Android. Let's see if I can run that. Well, there we go. Okay, so yes, it really exists on an Android device. If I can find the plus sign, I can do 2 + 2 here. There we go. Yes, so really works. We've been developing, in addition to the main Wolfram Alpha app, we've been developing an increasing number of apps that are based on Wolfram Alpha. One of the directions has been to make a sort of specialized app for every course. And the idea here is to organize the apps in the way that a typical course would be set up, and then to provide essentially templated ways to access the capabilities of Wolfram Alpha within the context of that particular course. And it's also more efficient when we're doing this, because we don't have to do quite as much linguistic processing. So we've been building towards an app for every course. We have about 16 or 17 of these course apps. We're also building out a collection of reference apps in all kinds of different areas. Let's see, maybe U.S. states reference app, for example. We can touch a state and find out about it. And we also have, so there's a whole collection of these reference apps that are coming out in lots of different areas. We also have some personal assistant apps like genealogy and history apps and so on. We have professional apps, like we have an app for network administrators that's out, and we have some apps for a variety of different kinds of professions and so on that are coming. So I expect by the end of the year we should be approaching 50 of these apps, all developed using the Wolfram Alpha API. It's interesting to see all these different pieces coming together. I mean, for example, between Mathematica and CDF and Wolfram Alpha and mobile, oops, switch screen, thank you. There's sort of some remarkable things that become possible of sort of machine models that have been uploaded, that come out as CDFs, that can be deployed on mobile, where somebody can be sort of standing in front of some machine in the field, typing something in to, or saying something to some Wolfram Alpha mobile app that then goes and runs in a model of that machine in the cloud and gives back results about what to do and so on. It's a pretty interesting collection of capabilities that become possible here. You know, we started off sort of very diligently over the course of many years building up Mathematica, gradually sort of adding more and more capabilities to the system. It's become sort of I think by far the world's sort of most spectacular algorithmic development system, and that's allowed many people to do many exciting things, including, I think, us, because we've been using our own system to build all of these kinds of things. So I think there's the main kind of message, if there is one, is a lot of exciting possibilities, a lot of pieces of technology starting to come together, a lot of things happening in the cloud, a lot of things happening on mobile, a lot of algorithmic development going on, a lot of opportunities, many, many more opportunities than there have been at any time in the past for people doing third-party development with Mathematica, with Wolfram Alpha, with various APIs, with mobile, and so on, opportunities for authors, et cetera, et cetera, et cetera. I like to think we built something pretty interesting, and that people will be able to make good use of it. And I should stop there. So thank you very much.